Good day everyone, today we shall be discussing GCD by Euclidean Algorithm. In the previous video, we were able to get our GCD and LCM by prime factorization method. If you haven't seen that, you might want to check that out too. Euclid used the long division method and some shifting pattern to get its GCD. That we shall soon see. Let's solve these two examples to see how to go about it. Without much stress, one can easily see what the GCD of 4 and 50 is. Of course, the HCF of 4 and 50 is 2, because that is the highest common factor we have in 4 and 50. Euclid will interpret this as 50 equal to 4 times some q plus some r, where 50 being the largest of the two numbers is the dividend, 4, the second number, is the divisor, times some q, the quotient, plus some r, the remainder. In view of this, 50 can be written as 4 times 7 plus 2. Of course, 4 times 7 being 48 plus 2 equal to 50. So, after that, the shifting is 4 will come to the place where 50 is, then 2 will move to where 4 is, then the statement becomes 4 is equal to 2 times what will give me 4, that is 2, plus 0 being the remainder. So when you get to a point where we have the remainder to be 0, you take a step backward to the previous remainder you got, which is 2 here. So that will be our GCD. Therefore, our GCD now will be equal to 2. So the GCD of 4 and 50 is equal to 2. I hope that is very clear. Let's go ahead to check the second question. Here, this can be interpreted as 200, which is the largest number, is equal to 132 times some q plus some r. Of course, 132 going 200 once, that's 200 is equal to 132 times 1 plus the remainder of 68. Of course, since we've gotten this, we move over to where 200 is, and that will be 132 is equal to this shift over here, 68 times 1 plus 64, which is the remainder. This becomes 68 equal to 64 times 1 plus 4 being the remainder. Then 64 now will be equal to 4 times 16 plus 0. Now on getting to 0, which tells the remainder 0, we take a step back to the previous remainder we got, which is 4. And now the GCD of 132 and 200 will be equal to 4. I hope that is very clear. The beauty of this algorithm is that it makes it very easy to compute the GCD of large numbers. Let's check this out. With this example here, one can easily say what the GCD of this is. Neither can one just think about a number that will go evenly, or the highest common factor that will go evenly within in the two numbers. It's quite difficult to come up with, but you don't have to go through that stress. With the help of the Euclid algorithm, all you just have to do is bring out the largest number to be equal to some multiples of the smaller one plus the remainder. So this obviously 1701 will go here twice, remaining 366, and then bring this over here. 1701 will be equal to 366, which will go 4 times, remaining 237. So bring out 336 will now be equal to 237. This will go also once. So if it goes once, remaining 129. Okay, now bring 237 to be equal to 129. We also go once, remaining 108. Then 129 we come out, then 108 will go just once as well, remaining 21. Now 108 will be equal to 21 times 5 plus 3. So bring 21 out. 21 now will be equal to 3 times 7 plus 0. So on getting to 0, you take a step back up, and hence our GCD will be equal to 3. I hope that is very clear. Let's compute the GCD for this number, and let's make it the last question we will be solving. By Euclidean algorithm, this can be interpreted as 4032 is equal to 2021 times some Q plus some R. Of course, this will go here once, so that's 4032 is equal to 2021 times 1 plus the remainder of 2011. So bring out 2021 will now be equal to 2011 times 1 also plus 10. Okay, I bring 2011 out, then I have 10 times 201 plus 1. Then bring out your 10. 10 will be equal to 1 times 10 plus 0. So I haven't gotten to 0. Take a step back. So our GCD is going to be 1 here. Therefore, the GCD of 2021 and 4032 is equal to 1. Do take note of something here. When the GCD of two numbers is 1, when you have your HCF to be equal to 1, HCF of two numbers to be equal to 1, definitely those two numbers are likely to be prime numbers. Of course, when you take a look at these two numbers, well, I'm not too sure of 2021, but I am very sure 4032 is not a prime number. This is divisible by 2, and of course divisible by 4. So that means if the GCD of these two numbers is 1, it implies that what? It is only 1 that can go in these two numbers, which means these two numbers are prime to one another. That's the meaning. So we say these two numbers are relatively prime to one another. But supposing we have the two numbers to be prime number, then we say the two numbers are co-prime. So if the two numbers are prime, they are primes, then we'll call them co-primes. I hope that is very clear. Why don't you all try this particular question? So compute this for me and leave your answer, drop your answer at the comment section. I shall try to evaluate and check who is very correct. Don't get confused by the three numbers you've seen there. With the three numbers you've seen there, don't get confused. Just know that what this can be broken down as the GCD of the first find the GCD of these first two numbers, 15 and 510. Then find the GCD of this entire number and 375. So the resultant value you got here, now combine it with this and find the GCD. So that will be all for now. If you are new to this channel, please hit the subscription button. If you haven't also, you should do the same thing. Hit the like button for this video and share. Thanks for watching.